Welcome. Today we're going to talk about polynomials. First, let's get a couple prefixes. We're going to talk about mono, bi, tri, quad, and poly. You probably know a few of these already. Mono means one. Bi means two, like a bicycle. Tri means three, like a tricycle. Quad means four, like a quad. Poly means many. Okay, so a polynomial has many terms. So here we go. A polynomial could be a monomial. So polynomial is a monomial or a sum or difference of monomials. So let's write that down. These are Cornell-style notes, so you want a question to which this is the answer, and please highlight the word polynomial. Terms are the monomials that make up a polynomial. They're usually separated by plus or minus signs. So a polynomial is composed of terms, and each term is a monomial. Mono meaning one. Okay, monomial means one term, and when you have more than one term, it's a polynomial. But even if it's only one term, we can still consider it a polynomial. So here we go again. A monomial has one term. A binomial has two terms. A trinomial has three or more terms. Well, that's interesting. I would think trinomial is exactly three, because after that we call it poly. All right, so a monomial, here's the definition of a monomial. It's a real number, okay, like 5 or -3 or even a decimal or fraction. Or it's a variable just by itself, x, y, z, p, d, q. Or it's a product of a real number and a variable, okay, with whole number exponents. So the only thing ruled out here are fraction or decimal exponents. And what fraction and decimal exponents are like, they're like square roots, or negative exponents create these fractions with the variable in the denominator, so we don't allow that. So a monomial may not have a variable in the denominator. So we're going to take a look at some examples and just sort them out. Either it is a monomial or it is not a monomial. It's easier than trying to understand every part of this is looking at it through the examples. Okay, so please write down these examples and we're going to label them as yes, it's a monomial, or no, it's not. Okay, beginning with 0.35 b c to the third power. In this case, the 0.35, that's fine. That's a real number. This is a product of a real number and variables, and the exponent is a whole number. So I would say yes, that is a monomial. As well, 5xy, same thing. You have a product of a real number and some variables. That's perfectly okay. 1/y is a problem. We have a y that's a variable in the denominator that's not allowed. This is not a polynomial or a monomial. 1/4 times p squared q is perfectly fine. A quarter is definitely a real number. P squared, whole number exponent, q, fine. And a minus 8 is not a monomial. In fact, that is a binomial, so we would say no. And there you can see you have two terms, a and 8, and they're separated by a plus or minus sign, in this case a minus sign. So we've got a few more examples. Jot these down and we'll say yes or no whether they are monomials. W divided by 9, yes, that's fine. The square root of a variable is not a monomial. That would be equivalent to m to the 1/2 power, which is not a whole number exponent. Okay, and same with AB over C. That over C, that's like the equivalent of having a negative exponent, which is not a whole number exponent. So we're saying no. On the next one, 3y to the -1. Again, that's not a whole number exponent, and m is just dandy. Okay, so hopefully that helps you see what is and what is not considered a monomial. In order to be a polynomial, it needs to be composed of monomials. So if there's a part of a polynomial that's not a monomial, then the whole thing's not a polynomial. All right. One of my favorite quotes from Yoda, do or do not, there is no try. Tell whether each polynomial is a monomial, a binomial, or a trinomial. 10. Monomial. 9x squared plus xy. Binomial. 2 terms. 8 minus y. Binomial. 2 terms. 5 plus x minus 3y. Trinomial. Although Yoda said there is no try. Okay, next topic is called degree. The degree of a term is the sum of the exponents of the variables in the term. So we're not looking at exponents on the coefficients, which are the number parts, only the exponents on the variables. Remember, if there is no exponent on a variable, it's a 1. Okay, so remember the sum of the exponents on the variables. So in this case, we're going to add the exponents 2 and 3, and the degree of this term is 5. Okay, you see how that works? You're adding up the exponents on the variables. So this part's pretty easy. Here's a few examples. Find the degree of each of these. And the first one's actually a little tricky because there is no variable, therefore the degree is 0. Next one. The degree will be 1 because if you don't see an exponent, it's a 1 and there's nothing to add it to. Okay. The third example, the answer is 3. And the last example, the degree is 8. Okay, so that's how you find the degree of a single term. How do you find the degree of a polynomial? Oh, and I just gave you a question to which this is the answer. The degree of a polynomial is the greatest degree of its terms. So here we're just going to find the degree of each term and choose the largest. Okay, for example, here's a polynomial. I would call this a quadrinomial. This polynomial has 4 terms. Let's find the degree of each term and then we'll choose the largest. So the first term, x cubed, has degree 3. Second term, degree 2. Third term, also degree 2 because 1 plus 1 is 2. And the last term has degree 0 because there's no variable on which to have an exponent. Okay, so out of these, which one's the biggest? 3 is the largest, therefore the degree of this polynomial is degree 3. Okay, so you just basically pick the biggest degree out of all your terms. Here's a few examples for you to try on your own. Good luck. First one is degree 1. Second example, degree 3. Third example, so we have degree 2, degree 1, and degree 0. 2 is the largest, and the final example is degree 3, okay, because it's bigger than degree 2. Okay. Last thing we'll talk about today is like terms, just to now we can understand what makes terms like each other. They have the same variable, it's true, so many of these have x, correct? But like terms also have the same degree. So that means that 3x squared and 10x squared both have the same variable x and the same degree too. So those are like terms, and they are not like 5x and 7x, which are different from one another. So then 5x plus 7x is 12x, and finally we have the constants 2 plus 3 equals 5. So this would be combining the like terms, which is actually tomorrow's topic, but there you have it. Okay. This picture of Abraham Lincoln was taken after the battle at Gettysburg, just prior to the Gettysburg Address.